Good morning, guys. Welcome to today's lesson, May 20th, Delta Math. Our aim, you can see, is how do we get 100% on this week's Delta Math. Remember, your Delta Math is due tomorrow at 8 o'clock, and in addition, your final project or your final exam, whatever you want to call it, will also be on Delta Math with very, very similar topics, some of the same topics, so the time to master them is now. All right, let's look at these factoring do now questions. You see the first one's negative 12x cubed plus 32x to the fourth. So between negative 12 and 32, we definitely have a common factor. All right, so what's the greatest number that goes into negative 12 and 32? That would be 4. And you can see that we also have a common variable of x. All right, and we could say that the highest exponent that are common to both is x to the third power. So our GCF would be 4x cubed, 4x to the third. Now we could divide each term by that GCF. All right, remember your GCF goes outside your parentheses now. Now we got to divide negative 12x cubed divided by 4x cubed. Those x cubes are gone. So we just have negative 12 divided by 4, which is negative 3. All right, now we have 32x to the fourth divided by 4x cubed. 32 divided by 4 we know is 8, so we have plus 8. And x to the fourth divided by x to the third is just x to the first power. Keep in mind you can check your answer by distributing and making sure that you get the original. And when you do that, 4x cubed times negative 3 is negative 12x cubed, so that's good. 4x to the third times 8x is 32x to the fourth power. So you're good to go. All right. Next, we have an example of, there's no GCF. All right, we should think next is an example of dots, and it is because 9x to the sixth power is a perfect square, and so is 1. And you might be thinking, why is 1? Because 1 times 1, right, is 1. All right, 1 times itself. So let's first take a look at 9x to the sixth power. Now, what times itself gives you, let's say if we were to take the square root here and we kind of break it up, what times itself gives you 9? That would be 3. And what times itself gives you x to the sixth power? That would be x to the third power. Okay. And same thing, if we took the square root of 1, that would be equal to 1, right? Because 1 times 1, right? 1 times 1 equals 1. Just like 3x to the third, if we took that and multiplied by itself, right? 3 times 3 is 9. X to the third times x to the third is x to the sixth. Remember, we'll be adding exponents there. And guys, that's just the thinking that goes into it. You don't have to show all that work. Okay, I just want to show you where the answer comes from, but you'll open up your parentheses now. We'll have 3x to the third, 3x to the third, 1 and 1, and remember with dots we have one addition symbol and one subtraction symbol. And we're good to go. The top just shows where we're getting all that from. Alright, next we have a classic example of AM, because the trinomial, right, in front of the x squared we have 1. In front of this x there, right, we also have 1. So we need what multiplies to negative 56 and adds to 1. Since we're multiplying to a negative, we need these signs to be different. Okay? It would actually be 8 and negative 7, because 8 times negative 7 gives you that negative 56. And when we add them, we do get that positive 1. All right, so your parentheses will have positive 8 and negative 7. And we just, for AM, we just put the x in front. So we have x plus 8 and x minus 7. And you're done. Okay, so factoring, huge part of Algebra 2. It's going to be almost your whole first quarter. Next year, market period 1, huge part of it is factoring, so make sure you have that down pat. Now, sort of a blast from the past here, we have right triangle proportions, which we know of as Hills or SAS. That's really where we have a right triangle and an altitude drawn in. You could see They say that exactly. Given we have a right triangle ABC, an altitude BD drawn to a certain hypotenuse AC. AD is 4, DC is 9. They fill that in for you. And we need to know the length of BD, which is the altitude. And they mark an X there for you. So remember, with these Hills and SAS questions, definitely important to label our segments, our legs, our altitude, of course, and remember, in total, the two segments make the hypotenuse. Okay, so we got to think about what are we going to be using. Are we going to use Hills? Or are we going to use SAS? Think about what's given, all right? These two segments are given, and we're looking for the altitude. So that would be a classic example in this one of SAS. So segment 1 over the altitude equals the altitude over segment 2. Now we substitute 4 over x equals x over 9. Cross multiply. We get x squared is equal to 36. Square root, and we get that altitude is equal to 6. All right, and that is definitely on this week's Delta Math and could also become your final project. Okay, same type of question. Everything's filled in for you based on what they told you, right? Right triangle and an altitude. So let's label again. We have our segments, our legs, the altitude, and the hypotenuse. So, is this going to be a Hills or a SAS? Hopefully you're thinking Hills. The reason is, guys, our hypotenuse is the unknown. Okay, and we're given the leg 1 and segment 1. Okay, so the altitude really isn't involved here at all. Remember, SAS, when we're looking for the altitude, is typically when we use SAS. But here, the altitude we're not given. We're not asked to find it, so this would be a classic example of Hills. And more specifically, Hills with the ones, since they're given leg 1 and segment 1. So our unknown hypotenuse, we're given leg 1, which we write twice for 9, and our segment. Cross multiply, we get 3x is equal to 81, divide by 3, and you get x is equal to 27. All right, another geometry topic that we haven't talked about too much lately, but it has been on every single Delta Math since the beginning of the year. All right, in the diagram below, BC is congruent to EC, very important. Right, that tells us we're dealing with an isosceles triangle. They tell us the measure of angle BEC is 66. They fill that in for you. And we need to find the measure of angle FCA, which you can see is located here. So if it's an isosceles triangle, they tell you 2 equal sides. We also know there are 2 equal angles, which would be these two here. Okay, so this angle would also be 66 degrees. And remember why that is, right? This angle opens up to that side. This angle opens up to that side. That's how you determine which angles are equal when you're given the 2 equal sides. So we have 66 and 66. All right, if you add those together, that gives us 132. Now to find that third angle of the triangle, we'll do 180 minus that 132, and that's 48. So that third angle of the triangle is 48 degrees. And now it's just a linear pair to find the angle in the exterior there. Angle FCA, the one they asked us for, that would be 132. All right. So moving along. Now we need to find the center and the radius given this certain equation. This looks like a long drawn out problem, and it would be if we did it algebraically. But up to this point, the only way I've shown you this is through GeoGebra. So you're going to graph the equation, find the center, find the radius. It is that simple. If you have GeoGebra, you might as well use it. So it's going to be x squared plus y squared plus 8x minus 12y plus 3 equals 0. Alright, you got a nice circle here. And you kind of have to eye it out a little bit, but you can pretty much determine where your center is. Just be careful. Your center point would be negative 4, 6. And the way you could check that, you could count from that center point to the right. Okay, it's 1, 2, 3, 4, 5, 6, 7 units. Make sure it's the same all around. If you go up, down, left from the center, it should be 7 all around. All right, so you count the boxes. You can see that if we went from here to here, that's 7 units. Here to there, 7 units. Here to there, 7 units. Here to there, 7 units. So you can determine that that's the perfect center of negative 4, 6, and also that our radius is equal to 7. So negative 4, 6, and a radius of 7. Alright. Factoring trinomials where a is greater than 1. Alright, level 2. Alright, you can see our a values here, guys. Right, are 2 and 3, which is, of course, greater than 1. Okay, so we got to use AC. A times C, in this first example, 2 times negative 4 is negative 8. So our values need to multiply to negative 8 and add to the B value, which is negative 7. Now if they're multiplying to a negative, the signs have to be different. So what multiplies to negative 8 and adds to negative 7? So we negative 8 and positive 1. Because negative 8 times 1 is negative 8, and negative 8 plus 1 is negative 7. So you open up those parentheses. One will have the negative 8, one will have positive 1. And now we don't just put x in front, we put 2x in front because the a value is equal to 2. 2x in front. And remember, you can break down usually one of the factors, sometimes two, but here we can just break down one of them. So you'll end up with x minus 4 and 2x plus 1. And remember, this is not your classic GCF, so that what we're dividing there, the 2, we don't throw that out front of the parentheses. You're done at this point. Alright, another example of AC. Right, A times C here would be 3 times 2, which is 6. Alright, so we need them to multiply to 6. Add to the B value of negative 5. So what are these values? What's going to multiply to a positive 6 and add to a negative 5? Since they're multiplying, right, since they're multiplying to a positive value, the signs have to be the same. Alright, but this would be negative 3 and negative 2. So your parentheses be negative 3 and negative 2. In front we throw 3x. We can divide here. Both of these can get divided by 3. The next factor, 3x minus 2, you can't divide anything. This would be x minus 1 and 3x minus 2. And we are done. Such a great way to factor these types of questions. Alright, and then factoring cubics. This is really one where you're going to have some sort of combination of factoring, because you see we have x to the third power. We really haven't learned how to factor that other than GCF, and that's what this is. Okay, it might be GCF in some other form of factoring, but at least to start, there's definitely a GCF. Let's think about the numbers first. 3, negative 30, and 27. what number can we divide all those by? The answer would be 3. And they all have at least x to the first power in common, so that's included in your GCF. So we divide out for each term. We divide 3x. This is GCF factoring, so 3x goes out front. And now in parentheses, we have 3x to the third divided by 3x. So that would be x squared. Now we have negative 30x squared divided by 3x. That would be negative 10x. And 27x divided by 3x, which would just be 9. So that's GCF. But look at what's in the parentheses, guys. That looks like a nice standard trinomial where a is equal to 1. So in addition, we still have AM factoring. So what multiplies to 9 and adds to negative 10? This would be x minus 9 and x minus 1. Don't forget that 3x is still out front. Right, because negative 9 times negative 1 is indeed positive 9, and negative 9 plus negative 1 is negative 10. So now we're done. So with this factoring cubic section of delta math, just make sure you're looking out for GCF and then something else, maybe dots, AM, AC. Okay? And that's it. Guys, your delta math, keep in mind, please do tomorrow. Make sure you're taking care of that. Message me and remind if you have any questions. All right, do not hesitate. And that's it. Have a wonderful rest of your day, and I will see you mañana.